Malbuster. It's a recent try-hack me machine and also a simple one. It explains the malware static analysis and a little bit of reverse engineering. I would say it's a beginner friendly room. Even if you are a beginner, have no idea about the malware reverse engineering, you can feel free to take this room because it is not having any in-depth reverse engineering stuffs. We are going to use certain tools and gonna perform a static analysis and find what are the things malware, a specific software does. And we are going to assist security operations center by performing the malware analysis here in this video. So without further ado, let's begin. And we got two tasks actually, and you may see this icon. So we've given two machines actually. One is Windows machine and another one is Linux machines. Both the machines are known for the malware analysis, and the first one is the Windows VM called Flare VM, and the second one is Remnux VM. So it is up to you. You can use either of these VMs to carry out this investigation, and I'm going to use the Remnux VM, which is given in the challenge 2, task 2. You can spin up any of these instances in order to carry out the investigation, as I said. So let me start this, and make sure you are connected to the TryHackMe's network. So I have connected to the TryHackMe's VPN. So I am on its network. So once the machine is spawned and the IP address is came, I'll be able to reach that machine. And I can either take that machine by clicking the show split view option, or they have given the RDP credentials. I can use any RDP software and I can do the login of the machine. And let's read through the scenario first. So here is the introduction. This room aims to be practice for dissecting PE headers and static analysis. In this scenario, you will act as one of the reverse engineers that will analyze malware samples based on the detections reported by your SOC team. So we sort of got our role here. And let's see the prerequisites. This room has some prerequisites. It is advised, but I would say it is not necessary. You can simply Google certain stuffs even if you don't have any idea about this, and you can finish it up, because the given prerequisites rooms are very easy difficult. I mean, the rooms with very easy difficulty, so that's why I'm saying. So this room requires basic knowledge of malware static analysis. We recommend going through the following rooms before attempting this challenge, and these are the 3 rooms, and 2 out of 3 rooms have already been launched, so you can feel free to check out this one. I've already made a video about this intro to malware analysis, and I'll post the link in the description so that you can refer that what is malware analysis. I tried to explain it simply. Well, let's read through the scenario. You are currently working as a malware reverse engineering for your organization. Your team acts as a support team for a SOC team when detections of unknown binaries occur. So one of the SOC analysts triaged an alert triggered by binaries with unusual behavior. So from this line, we can understand a specific binary found to be generating some suspicious network traffic, and they have extracted that binary and given to us. So our job is to reverse that binary and find what it does. Your task is to analyze the binary detected by your SOC team and providing information assisting them in remediating the threat. Well, that is the objective. And investigation platforms. So as I said before, we have given Flare VM and Remnux VM. Flare VM is built upon the Windows and Remnux is built upon the Ubuntu operating system. So that is the difference between these two, and also the tool set will be differ, obviously. Well, we can use either of that. As I said, that is the thing. And here is the warning. Lastly, you may find the malware samples on this one. So looks like they have kept the malware samples on a folder called samples, which exists in the desktop itself. And here is the very important advice. We advise you not to download the malware samples to your host. This is very important, because I was kind of lethargic while reading this message for the first time, and I have got into that machine. I have accessed their machine and found all those 4 malware samples are very notorious, and it makes sense. You shouldn't download those softwares, those executables in your machines. If you execute this binaries inadvertently, then the consequences would be severe. So that's why they are recommending you to not download the samples. So we need not to worry. We can carry out the entire investigation on the remote machine. This is just for learning. Well, all right. The machine is spawned 10.10.33.25. So which is the machine, but we are not going to connect it through the RDP. Instead, I'm clicking show split view button. So it will be opening that machine in half of the window. So look at the machine. The machine is done. It is spawned. You can see the folder called samples present on its desktop. Well, I'm opening it in a full screen so that I can see the machine in a new tab. Well, yeah, now it looks better. So this is what I'm exiting the split view from here. All right, the first one, I think it is done. We are ready to analyze the sample now. Let's see anything else we need to focus. Nothing. We can in the second task, you can see obviously it is a part of questions. So we have to answer these challenge questions given. Well, in order to answer these questions, obviously you should know what to do with that binaries. What you should do with these binaries. And you can see the 4 binaries named Malbuster 1, Malbuster 2, Malbuster 3, and Malbuster 4. So these are the 4 malwares that they have mentioned. So this is the window. So let me open it in the CLI. Let me zoom in this CLI window. That's perfect. I'm getting into desktop and samples folder. And yeah, I'm ready to start the investigation now. Let's see what's our first question. Based on the architecture of the binary, is Malbuster 1 is 32-bit or 64-bit application? So it's a simple one. First of all, we need to find the architecture of the first malware, Malbuster_1. So let's try to find that. So I'm using simple file utility of Linux. So here is the input. So it is only giving the actually it is giving PE32 executable. Look at this, PE32, and also it is saying that it's a graphical user interface compatible application, and it is built for MS Windows. Okay, now I'm going to introduce another tool called petree here. Petree is a tool similar to PE Studio that you use in the Flare VM. Actually, it is like a Linux version of the tool. So it is one of the PE analysis tools, the PE file analysis tools that is compatible with the Linux devices. Well, the tool is already pre-installed here. So I'm just typing PE and entering. So let's see what we are getting. We are getting a bunch of tool list. petree is one among them. So I'm going to use this petree in order to analyze the sample Malbuster 1. So let me do that. I'll paste this name and Malbuster_1 and the binary name. Now let's see what happens. It will take some time when you are running this petree tool from your system because it will be trying to read that entire binary and the parts of the binary sections, those things and all. So that's why it is taking some time. Well, let's wait for this. And before that, let's read through the next question. What is the MD5 hash of the Malbuster_1? So which is very, very simple. We can use multiple tools to find the MD5. Even petree tool can give the MD5 hash of the Malbuster binary. Sorry, any binary. So look at this. This one is straight away giving the MD5 hash of the binary. We got the answer to the second question, but the first question we had to get. So let's try to read the headers first. So in the header, we should be getting the details about the architecture, whether it is 32-bit or 64-bit architecture. I'm just trying to read that. So let's read through this. Look at this. In the file header, I just expanded this part, image NT headers. Under image NT headers, there is an option called file header. Under the file header, I can see the characteristics, and here it clearly says it's a 32-bit machine. So that would be our answer now. So I'm simply copying this one and pasting it here. So the answer should be either of this. All right. And that's the right answer. And what is the MD5 hash of the Malbuster 1? So we've already got that as well. We can copy this from here, or simply you can use a utility called MD5 sum. Not here, I think on the TryHackMe's machine. So here you may simply use MD5. Let me open another CLI window. Yeah, desktop samples, and here MD5 sum utility in order to calculate the hashes. Malbuster underscore 1, and here is the hash. So you can calculate the hashes by using the binaries like MD5 sum, SHA1 sum, SHA256 sum, like that. Yeah, that's the right answer. And moving to the next, using the hash, what is the number of detections of Malbuster 1 in VirusTotal? Now, out of that petree utility, we are going to do some other investigation. Like we are going to carry out the investigation on VirusTotal. We got the file hash value. So by using this hash value, we can search in the online platforms like VirusTotal. So which will obviously give you the outcome. So look at this. So here is the VirusTotal search made for this hash value, and see how many detections. That's the question. So it is asking like how many number of, the number of detections of the Malbuster 1 binary in VirusTotal. Well, that's the question, and you can see 51 security vendors out of 71 detected it as malicious. So that's what our answer. That should be our answer. So let's see, and that is okay. The next one, based on the VirusTotal detection, what is the malware signature of Malbuster 2 according to Avira? Now they are asking us to find the the malware signature for the Avira. You can see Avira is one of the security vendors listed here. Avira no cloud. So this is what this string is what called the signature. So they are asking the Avira signature for Malbuster 2 binary. Well, we are having that Malbuster 2 sample here. We need not to copy that sample and paste it in the VirusTotal in order to witness the signatures. Instead, we can simply find the hash value, and you can simply paste the hash in VirusTotal in order to get the whole details. So it is very easy. MD5 sum. That is where the hashes comes in handy. So look at this. I'm getting the MD5 hash now. MD5 hash of Malbuster 2. So let me search for this hash. So here is an option to search. I'm pasting this binary, this hash value simply, and it is giving me the list of signatures for this. 56 vendors detected it as malicious, and you can see the Avira. So here is the signature. So this is what we need, and that's the right answer. Moving to the next one, Malbuster 2 imports the function core exe main. From which DLL file does it, from which DLL file does it import this function? Okay, now you can see that specific function name. So we have to investigate, we have to go through that petree outcome of this Malbuster 2 binary and find this core exe main function. And first of all, we have to confirm whether this function is present in Malbuster 2 or not. If it presents, then we need to find the DLL file which imports this function. So obviously a binary, the dynamic binary depends on certain DLLs, right? So we are going to find one of such DLLs. Now let's see that. Okay, now I need to move to the another terminal. I already opened the session for the petree session for the Malbuster 1 binary. Now I am going to open the Malbuster 2 in the petree utility. So it just took few seconds to open. Now it is opened. You can see when you expand this, you'll be able to see some basic details. And I'm just trying to expand this stuff. Let's see what we are getting. We need to find the function that is mentioned here, core exe main, and we need to find from which DLL this function has been imported. Well, that is our objective now. Let's see. I'm just expanding this part one by one. and you may see the subsystem, it is Windows GUI. So here it says whether it is CUI or CLI or GUI binary. And look at this. So here is the entry import, and I think I'm just seeing the memory address of every sections .txt, .resource, .reloc, .text, like that. I'm just scrolling down. Let's see. And the bottom one, I can see it is image import descriptor. So let's open that and look at this. There is only one DLL here. Looks like the only one DLL is being imported. And is that DLL is having the function? Yes, it does. Look at this. MS core with we.dll. This is the DLL name, and it does have the function name core exe main. So looks like this could be the DLL name that we are looking for. MS core with we. And yeah, that's the right answer. All right. Now, moving to the next question. Based on the VS version info header, what is the original name of the Malbuster 2? Well, VS version info. If you're not familiar with this, then look at this, the result of the PE tree. Look at the end. The last header you can see here. Actually, it denotes the VS underscore version info. So this is the header they are talking about. And I'm just scrolling down, expanding this header, and here I can see the original file name of this binary. And look at this one. So this is the value we need. So here is the original file name of the malware, and I'm pasting this one, and let's see. And yeah, that's the right answer. Well, moving to the next one. Using the hash of malbuster underscore 3, what is its malware signature based on abuse.ch? Okay, abuse.ch, and they are talking about the platform that is that is being run by abuse.ch. Abuse.ch is running multiple platforms like Malware, Bazaar, and URL Horse. So let me type abuse.ch and Google. So let's see what we are getting here. And you can see the platform of the abuse.ch. So let me Google it first. I'll Google abuse.ch instead of getting into that website. And you can see abuse.ch is having Malware Bazaar, URL Hash, ThreatFox, and Fudo Tracker. Well, the Malware Bazaar is one among one among the malware repositories out there, and from here we'll be able to download the list of malware. So let me search the hash value of Malbuster 3 in this platform, whether we are getting any signature in Malware Bazaar. So let's see that. So Malbuster 3, we need to find the hash value here. Let's find that. Yeah, here. Now let's get into this one, Malbuster 3, I guess. So I'm simply finding the SHA-256 hash of Malbuster 3. And here is the SHA-256 hash value. And this is in my clipboard. And I'm going to browse window. I'm not robot. And look at the list of executables. All these files are malwares. And I'm simply searching for the specific SHA-256 hash, and here I am getting the file, and you can see the signature here. The signature says it is TrickBot malware. TrickBot is one of the popular malware loader out there, so it is very popular. Threat actors often use this kind of malwares to gain the initial access into the target system. So the TrickBot is the name. Let's see. Yes, that is. Okay, and the next one, using the hash of the Malbuster 4, what is its malware signature based on abuse.ch? So let's do the same for Malbuster 4 binary. Well, yeah, here is the hash. I'm doing the same search once again with different hash. And yeah, look at this. The signature says it is zloader. Well, zloader, let's see what is zloader. Zloader malware. It's a botnet. From the search itself, we can see it's a botnet. Zloader is a Trojan designed to steal cookies, passwords, sensitive information. Here it says Trojan. Looks like it does have multiple faces. Um, Microsoft disrupts Zloader malware in global operations. Zloader is widely known banking Trojan, first spotted in August 2015. Look at the year and month. Looks like it's a veteran malware. All right, now we got that Zloader, that is the answer. Let's give here. And yeah, okay, now moving to the next one. What is the message found in the DOS stub of the Malbuster 4? Well, in order to find the DOS stub of the specific sample, we are again going to the petree outcome of the file, and we have already opened it with, we have already opened the petree session of the Malbuster 2, I guess. So I'm just trying to let me, yeah, and here I'm opening Malbuster 4. I think that's what we need to do now. Malbuster 4 DOS stub we need to find. So let's do that. And it opened in few seconds. So here is the thing, and look at the headers here, DOS stub. I'm just clicking it, and here the DOS stub is expanded, and you can see the message here. This solfram cannot be run in DOS mode. All right, so I'm simply copying that message and pasting it here. That should be the answer, yes. All right, and the next one, Malbuster 4 imports the function shell execute A. From which DLL file does it import this function? All right, now you can see it gave the function like this question. They gave the function, and by searching for this function, we need to find the pertaining DLL and the DLL name. Now let's see, we have already opened this file in the petree. All we need to do is expand this import descriptor and look at the list of DLLs, and the function name says shell execute A. So it looks like it is related to the shell, reverse shell, bind shell, whatever. So it is related to the shell, right? So let's see what is the DLL name that is related to shell here. There is one name called netshell.dll. Let's expand it. It doesn't have that specific function. And moving forward, there is another DLL called shell32.dll. Let me open this one, expand this one, and here you can see the shell execute A function, and it is actually a Windows 32 API call. So if you search for this shell execute A in Google, you will be getting that meaning for this shell execute A call. Shell exec A, I guess. Execute A. Look at this one, shell execute A function in shell API.h. And if you see this Microsoft documentation, you can understand what this shell execute A does. And they gave the clear explanation. Not only for this, any function you can take, if it belongs to the Windows, it is belongs to the Windows 32 library, then you can find it here in the Microsoft document site. All right, now we found the answer. It is nothing but shell32.dll. Let's answer that. Yeah, and moving to the next part. Next question. Using Capa, how many anti-VM instructions were identified in Malbuster 1? So far, we have been using petree, SHA-256, SHA-1, MD5 some utilities of Linux, and file utility, barely. Now, we are going to use another utility called Capa. If you are not familiar with this name, let's Google this and learn what it is. Capa tool. You can see the GitHub page as a first result, and it belongs to Mandiant. Mandiant is one of the security organizations who does cybersecurity operations, I suppose, and they have launched this tool called Capa, and let's see the description of it. The Flare team's open source tool to identify capabilities in executable file. Well, the Mandiant is the one who launched the Flare VM, I guess. So let's confirm that as well. Flare VM. And yeah, Flare VM belongs to Mandiant, and the same company has released this Capa utility, and you can see Capa detects capabilities in executable files. You run it against any executables like PL, ELF, or .NET or shellcode file. It tells you what it thinks the program can do. For example, it might suggest that the file is a backdoor, is capable of installing services, or relies on HTTP communicate. Whatever its capability, this tool try to identify the capabilities of that file, and it displays to the end user. And you can see one example here. They have ran the Capa utility against this suspicious executable, and it gave the Mitre attack tactic and technique, and also its capability along with the namespace details. So this is how a Capa outcome would look like. Now let's do the same. The specific Remnux Linux VM is already coming with the Capa tool installed, so you need not to do anything newly. So let's follow this. I'm simply typing Capa, and it is already installed here. So let's see its version. Looks like it is taking some time, but it is already installed. So when I press the tab, it was showing the name. So yeah, look at the name. So look at the version. This is the version of Capa is installed. So I'm simply calling the Capa binary and the malware that I need to analyze. We need to analyze the Malbuster 1. So that is the binary we need to call. So let me give this as an input. You can see it is loading. It will be taking some time to throw you the results because it is taking time to read the binaries thoroughly. And you have to wait for few seconds to get the fascinating outcome out of Kappa. All right. Now, meanwhile, let's see the next question. Using Kappa, which binary can log keystrokes? Well, it is clear that they didn't mention any specific binary. We are going to run Kappa against all 4 binaries and find which one has the keystrokes capability, the capability to record the keystrokes. Well, all right. Now we came back to this and look at the results here. The Kappa results of the Malbuster 1, and it has its hash values, operating system, format, architecture, and the path. And look at this. Here is the Mitre attack tactic. Obfuscated file or information. Looks like the file is obfuscated, and virtualizations and sandbox evasion is present here in this binary. So it tried to evade the virtual box or whatever the VM you are using. And the next one is MBC objective. So look at this. It does have some capabilities: anti-behavioral analysis, communication, like it establishes the HTTP communication, cryptography. It uses these cryptographical protocols for encryption stuff, and data defense evasion. Look at this. It uses the obfuscation in order to evade the detection. And discovery. So there is a behavior called code discovery. So there are a lot of capabilities for this malware. And let's see what is our question here. How many anti-VM instructions were identified in Malbuster 1? So we are looking for the anti-VM capabilities. So let's see. I can see one, the virtualization or sandbox evasion. This is an anti-VM capability. So one, and the next one is virtual machine detection, anti-behavioral analysis. So there are 2 capabilities so far. And moving to the next, do I have any other VM related stuff? And look at this, reference anti-VM strings. So anti-analysis. So it is having another anti-VM capability. So there are 3 anti-VM capabilities found here in this uh, Kappa outcome. So I am just giving 3 and see. Yeah, that's the right answer. All right. Now using Kappa, which binary can log keystrokes? Well, in order to find that, we need to run this Kappa for against other 3 malwares, because this is not logging any keystrokes, right? This specific sample. So let's do it for the other VMs. Capa against Malbuster 2 and Malbuster 3. We'll be taking some time, and let's read through the next question. Meanwhile, using Capa, what is the MITRE ID of the discovery technique used by Malbuster 4? So for that we need the results of Malbuster 4, fine. And the next one, which binary contains string God mode? Well, this is a different part. We can use the utility called strings, which is one of the basic utilities which will be helping you when you are analyzing a binary. The string utility simply displays the human readable letters as keys from that binary. It extracts all the human readable characters and it displays in the string outcome. So that's what we are going to do. And look at the last question. Which binary contains the string, the user agent, the specific user agent? So even this one can be found by using the string utility, but before that we have to find answer for these two questions from Capa. So let's do that. Running for running Capa against Malbuster 3. So it will be taking few seconds. Let's wait for that. Now I ran the Capa utility against all four malwares and I'm looking at its capabilities. I need to find the keystroke capability and I'm scrolling up. So now looking at the results of Malbuster 3, and here I can see the log keystrokes via application hook and via polling. So looks like the Malbuster 3 binary is what does the keystroke logging. So let me give that here, and that's the right answer. And moving to the next, using Capa, what is the MITRE ID of the discovery technique used by Malbuster 4? So let me scroll all the way down, and I've already ran the stuff, and you can see here is the Malbuster 4 binary, and you can see the attack tactic, it is discovery, and the technique ID is given here. So this should be the answer. This is what we need to enter here. Yes. All right. Now we have done with the Capa. Now we learned what the Capa tool is capable of doing against any binary, any unknown binaries. Now it is time to analyze some strings. And as I said, we do have string utilities, and which comes very handy. So let's do that. Strings utility, and we can run strings against any binary. So it will be bringing the human readable letters from the binary. So look at this. Actually, it throws a lot of outputs. So we can use a command grep in order to filter out the specific string. And here we need to find the string God mode. Which binary is using string God mode in it? So I'm using grep and I'm trying to find the God mode string. It is not present in Malbuster 1. Doing the next, and look at this. The strings of Malbuster 2 contains a word called God mode. So then this should be the answer, Malbuster 2. And moving to the next, which binary contains string, this specific string? Mozilla /4.0, the user agent. And let's do the same. First, I'm running this. Here, this specific string contains the spaces, so I'm putting it within the double quote. And the Malbuster 1, that's the binary contains this user agent. If I run this against the other binaries, I won't be getting anything because it is not there. The answer should be Malbuster 1. So that's the answer. And yeah, here we've done through this room, we have learned some basic stuffs. Once you get the suspicious sample, initially what you need to do. So I have shown certain tools, and not only the tools that I have used, there are plenty of other tools that you may use. If you use Flare VM, there will be a lot of other options. So it will be containing some separate tool sets to analyze the PE files, and even the Capa is present in the Windows operating system. That would be the same, but there will be a lot of other tools to use for this PE file inspection. So I used PE tree. There are other tools like PE bear, a PE Studio, like that. So it is up to you to choose the tool which is comfortable to you. And yeah, this is what I wanted to explain. Hope you really enjoyed it. If you really did, consider subscribing my channel and ring the bell to get notified. And if you have any other opinion, drop it in the comment section. I'll try to respond your valuable questions. And you can also share this video with your friends. I'll catch you next time with another exciting one. Until then, I'm signing off. Cheers, and I love you all. Thank you so much.